Dear colleagues, as we unfortunately have canceled this year's World Congress in Montreal, we thought it would be a good idea to at least share some highlights from the virtual Congress that took place back in February. Before the video starts, I would like to announce that we will open the Symposia submission website in July again for the 2022 World Congress in Taipei, Taiwan. I look forward to seeing you there in person next year. And now please enjoy the video. Oh, and don't forget to subscribe to our YouTube channel below for free so that you can watch more video in the coming weeks. Thank you.
It's a pleasure to have the opportunity to present to you today, and thank you very much for attending this lecture. Today, I will be talking about the neurobiology of social isolation, a portal to psychopathology. And I thought I'd start with a brief introduction about how I got into this topic. I had not really thought about the neurobiology of social isolation at all until the pandemic hit us. And I also had the advantage that I was asked by the National Institutes of Mental Health to give a lecture about social isolation and suicide in late life, and to talk about it from the point of view of neurobiology. So that led me to do a detailed review of the literature. And what I found was really incredibly interesting, a bit daunting, and I think illuminating in terms of what we might anticipate in these days of pandemic and the need to be socially isolated and socially distant. So thank you, PIC Regions. And loneliness is an interesting concept because in all likelihood, its consequences are probably evolutionarily protective. And at the same time, it appears to prevent a negative feedback loop. So of course, we know that it's adaptive to have connections with others. We are social animals, and we know that being in a cohort, in a group, ensures safety and survival. So being isolated, of course, presents a danger to the individual. And so it triggers some self-protective responses, such as hypervigilance for social threat, or anxiety and hostility. If you think about it in this context, many of the behavioral and biological changes that I'm going to describe make sense. And this is a really interesting model of the effects of loneliness on social cognition. And if you start from this top circle, you can see that perceived social isolation, I think it's important that it's perceived because not all people who are alone or socially isolated feel lonely, and not all people who are in social groups feel a lack of loneliness. So it's this perceived social isolation that leads to implicit hypervigilance for social threats. So the animal or the person becomes more likely to be scanning the environment for social threats. They may develop confirmatory, they have confirmatory attention, so they have a bias in their attention towards events in the environment that confirm their thought that they should be vigilant for social threat, and that leads to memory biases as well. And it leads to a development of a behavioral confirmation process by which the individual or the organism displays more negative behaviors, more negative social interactions and affect, leading to a repulsion and isolation from the social environment, leading to a strengthening, if you will, of this loop. Here's another example of sex-dependent effects of social isolation. And this experiment is in isolated male and female hamsters. And what they found was that in the isolated groups, here you can see that the isolated males and the isolated females displayed more aggressive behavior, again, using this resident intruder task. But they also found that the isolated males and females pursued much more social behavior, but were less engaged in terms of non-social behavior. And interestingly, when they looked at the biological mechanisms, what they found was that the vasopressin 1A receptor in the dorsal raphe nucleus was lower in the male hamsters compared to in the isolated male hamsters compared to the group housed male and female hamsters and the isolated female hamsters. This is relevant because the activation of the dorsal raphe vasopressin 1A receptor increases serotonin neuron activity through a glutamate dependent mechanism. And since the dorsal raphe nucleus provides about half of the serotonin innervation to the anterior hypothalamus, this is really critical for behavior. So a reduction in serotonin release in the anterior hypothalamus would increase aggression. This decrease in vasopressin 1A receptor in the DRN by social isolation then could be contributing to the aggression promoting effects of social isolation by reducing serotonin release. And one thing that I noted is that in this article, they don't really mention what the timing of the social isolation is, whereas many of the experiments have social isolation occurring early on. And of course, social isolation also has an impact on not only on the HPA axis, but also on GABA receptors and neurosteroids. And this is a study of cells from cerebral cortex and hippocampus of rats that had either been group housed or isolated. And basically the study was looking at the impact of potentiation of GABA evoked currents in response to exposure to diazepam. And here you can see that from white to and across these different gradients, there's an increment in the amount of diazepam. And what you can see is that the group housed animals have a dose effect, but a much more pronounced effect in terms of GABA evoked currents than those who are isolated. And this was true not only in the cerebral cortex, but also in hippocampus. Interestingly, the socially isolated rats had reductions in cerebrocortical and plasma progesterone and its metabolites. And we know that progesterone is very important in terms of stimulating both anxiety-like and depressive-like symptoms. And basal ACTH was also slightly decreased. And the HPA axis response to an acute stressor in these cells was markedly increased, as were the GABA receptor mediated inhibitory currents in the dentate gyrus, which of course is in the hippocampus. So here you see again the impact and the dampening of isolation that isolation has on responses to stimulation or a stressor. So I'm going to shift gears and talk briefly about suicide. And in particular, I hope that I've made a good case that the effects of social isolation impact many circuits that are and systems that are very relevant for psychiatry, including the hypothalamic pituitary, adrenal axis, monoamine levels, GABA receptors and excitability, the hippocampus and hippocampal volume, as well as sleep. And interestingly, as I mentioned to you, I got into this because of a request from the National Institutes of Mental Health. They asked me to talk about social isolation in suicide. And we had developed this, some work by Dr. Barbara Stanley and myself, where we developed these two different models for impulsive suicide attempts compared to more planned, more lethal suicide attempts. And in the impulsive type, we think that childhood adversity leads to reactive aggression, poor cognitive emotional control, and HPA reactivity. And as you saw in the animal models, these two are very clearly related to social isolation. And in the context of a life event, the individual develops suicidal ideation very acutely and engages in impulsive suicide attempt. In contrast, the more planned ones happen in individuals who have high serotonin 1A binding potential, which is a signal of low serotonergic tone, if you will. And these are not aggressive individuals. And in this case, what we see is that in the context of a depressive episode, you have sustained suicidal ideation, which leads to the ability and time to plan and eventually result in more lethal events. And so I show this because it very clearly calls out several of the behaviors and systems that were illustrated in some of the data that I presented to you. But importantly, when I looked at this really beautiful illustration cartoon about the impact of loneliness and social isolation, you can see here the impact of loneliness and social isolation on the HPA axis, right? Both through ACTH secretion as well as the secretion of glucocorticoids, but also in the sympathetic nervous system, as well as in the inflammatory nervous system impacting cytokines, as well as, and which lead, of course, to inflammation and oxidative stress and glucocorticoid resistance. And here you have, again, the sleep disruption and the physical inactivity and smoking. And it was really interesting to me because when I looked at this, I was stunned because it was very similar to some of the things that I had written up. This is a paper from 2014, looking at the biological underpinnings of suicidal behavior. And here you can see again the impact of CRH and cortisol, so the HPA axis, and the impact of cytokines, importantly also having an effect on these serotonin downstream, as well as glutamatergic effects. And so I think that this makes an interesting case for the anticipated negative impact that we can expect from this pandemic, not only because of the direct biological effects on the CNS by the the SARS-CoV-2 virus, but also by the effects of quarantine and social isolation in terms of both behavioral and neurobiological consequences. And I know that in many cities, certainly in New York and in Philadelphia, we've seen an increase in the rate of murders and violent crime since the onset of the pandemic. And I think we can now start to understand some of the biological drivers of those changes.